Hello, and welcome to the video for 5.5, Properties of Parallelograms. By now, you are addicted to the videos. You can't get enough. You love getting a nice cup of hot chocolate, settling onto the couch, and watching this video. So I will keep obliging you and making these videos, with today's being Properties of Parallelograms. So please write down 5.5, Properties of Parallelograms. And a big thing you need to know here, we practice on the board the activity that we're going to do every day, where you have to put the shape underneath what is true about it. And the key thing to know here is that anything that's true about parallelograms is also true about rhombuses, rectangles, and squares, because rhombuses, rectangles, and squares are parallelograms. So anything we learn about parallelograms, those are applied to rhombuses, rectangles, and squares. And that's important to know. Let's start by talking about what a parallelogram is and what it looks like. So what you first need to do for a parallelogram is you can draw two parallel lines. And again, I'm going to draw these too big for what I need, and then I come over and I draw two other parallel lines. The way I'll do that on the computer is just copy and paste. And here is the parallelogram that we're looking for. And what I want you to see is that this part is specifically the parallelogram. Now, I'm using my mouse for all these drawings, so they're going to be really horrible, or as many of you so eloquently put, is going to be scan. So we will label it scan because of how poor the drawing is. And when you label a parallelogram and when you name it in order. S-C-A-N. You don't go S-A-N-C. Okay? So there's my scan parallelogram. That's what it looks like. It's the key to know that. I'm going to erase it so you can see, but it's definitely the two lines are parallel, that are opposite of each other, and the other two lines are parallel, that are opposite of each other. Now, a couple things, and I want you to write these down. You do not have to draw that last drawing. Is the conjectures. The first is the parallelogram opposite angles conjecture. The opposite angles of a parallelogram are congruent. So that means that the angles opposite of each other are congruent. And then the other two. So you have two pairs of congruent angles, but they are not congruent to each other unless they're a special type of parallelogram. So that's what that looks like. Include the drawing, please. A parallelogram, consecutive angles conjecture. The consecutive angles of a parallelogram are supplementary. That means if this is 1 and that is 2, then angle 1 plus angle 2, look at that great handwriting, it's so beautiful, equals, and supplementary means that two angles add up to 180. Another word for that is linear pairs. Linear pairs add up to 180. Okay? So that's all that means. If this one's angle 1 and that one's angle 2, they add up to 180. If that is 3 and that is 4, 3 plus 4 is 180. Parallelogram opposite sides conjecture. The opposite sides of a parallelogram are congruent. So as the opposite angles are congruent, the opposite sides are congruent. And you can see that how I'm marking this. The parallel sides, they are parallel and they are opposite and they are congruent. And the final one is the parallelogram diagonals conjecture. And the diagonals of a parallelogram bisect each other. So let's see this perfectly straight diagonal. These bisect each other. That means that this part of the diagonal and that part of the diagonal are congruent, and it means that this part and that part are congruent. But it does not necessarily mean that the red and the blue marks are congruent to each other. These are big things to know, and we go over this every single day. So have your notes out when we do this activity. Now what we're going to talk about is vectors and how they apply in real life. Now, as you can see, vectors are used for velocity, acceleration, force, and sometimes for villains in movies. In Despicable Me, there was a genius villain named Vector. If you remember that movie, he introduces himself by talking about what a vector is. He says, "I'm Vector. I am committing crimes with both direction and magnitude. Oh yeah!" And he's a great villain. And he was right. Vectors are a arrow. The arrow represents a vector, and they represent magnitude and direction. So what I want to make sure you see is how this applies to things you might know. Because one thing it can do is the vectors can tell you the speed and direction of an airplane, a boat, how fast you're running, your car, any of that. And physics problems really use vectors. So any of you that have taken physics or are taking physics, use vectors a lot in physics, because you'll have to combine vector quantities that are acting on the airplane or on the boat or whatever object it is. So let's say there's an airplane, and the airplane has its own speed from its engine and its own direction from the pilot. But there's also a wind current, and the wind current is playing a part on which way the plane goes. And those are going to be called the resultant vectors, and you'll see that in the next slide. But look down here at this plane. So let's say we know how fast and what direction the plane is going. I'm going to kind of mark over it in red. That's the plane's direction and speed. And we'll say it's 560 miles per hour up here. Then you have the wind. And the wind current brings it 80 miles an hour this direction. And the way you'd find which way the plane would actually travel, which way the plane would actually go based on the engine and the direction the pilot's taking it, and the wind and the speed of that and the direction it's taking it, is to draw a parallelogram. And you would draw a parallel side of the red, and you draw a parallel side of the blue, and the resultant diagonal. So I start from the plane, and I draw the resultant diagonal. That's the actual direction of the plane. So you can pause that and see that video, but I'm going to redraw it on the next slide. And this is what I want you to write down. Vector, a quantity that shows both magnitude and direction. Oh yeah! The resultant vector or vector sum. And this is the important thing. And I've drawn it right here. That is the resultant vector. You have the black arrow is the plane, for say, or the boat. Then you draw that parallel from the blue vector, which will say the wind, and you draw another parallel blue line. And the diagonal, which is in red, is the resultant vector or vector sum. And I do want you to write down that the resultant vector or vector sum is a single vector that has the same effect as combined vector quantities. So if you have the airplane moving and then you have the wind pushing against it, the resultant vector or vector sum will be the red line. So you can pause this and go ahead and write those down. And so this is just a quick example. You have a helicopter. It's pushing one way. You have the velocity of the wind pushing the other way. You draw the parallel, and I drew it too far, so you don't have to worry about where it is. You draw another parallel, and then you'd erase anything that's extra. And the diagonal would be, pick the wrong one, from where the helicopter starts, the diagonal would be the resultant vector. And again, same here with the boat. Draw the parallel, and the diagonal would be the resultant. The diagonal is always from the object. So pause this if you want to kind of see and make sure you understand it. The one with the arrows is the resultant vector or the vector sum. Last slide. I know it's a lot of information, but this is just stuff that we're working on with the activity, where you have to put your shape beneath what is true about it. Now the first one is a great one, the double-edged straight-edge conjecture. I don't know why it's called that. I love that name. It's so confusing, so complicated. And really all it's saying is, here's the restrictions that make a parallelogram a rhombus. So I do want you to write all of these things down. if two parallel lines are intersected by a second pair of parallel lines. Now that just means a parallelogram. So you could say, if an object is a parallelogram, if you want to write the notes, if an object is a parallelogram, and the sides are the same distance apart as the first pair of sides, then the parallelogram formed is a rhombus. So you can either write that definition, but the first part of the definition is just basically saying it is a parallelogram. Okay? And then the second part is explaining what has to happen, what restrictions there are that makes the parallelogram a rhombus, which is that they are the same distance apart. The parallel lines are the same distance apart. That just means all the sides are congruent, which is a rhombus. Then you have the rhombus diagonals conjecture. The rhombus diagonals conjecture says the diagonals of a rhombus, and that's the key word, the diagonals of a rhombus are perpendicular and they bisect each other. So again, that's one of the questions up there. That's one of the things we do for the activity. It says diagonals are perpendicular or diagonals bisect each other, and you can say that a rhombus, that is true. Rhombus angles conjecture. Again, the diagonals, we're talking about the diagonals of a rhombus, bisect the angles of a rhombus. There's one up there that says the diagonals bisect the angles. Well, rhombus is one of those. The rectangle diagonals conjecture. The diagonals of a rectangle are congruent and they bisect each other. Again, another piece of information that we're going to be covering every day. It's going to be good to know. And the last one, the diagonals of a square are congruent, perpendicular, and bisect each other. And what you'll notice here is that the square kind of combines the rectangle and the rhombus, because a square is a rectangle and it is a rhombus. A rhombus has 4 equal sides, but the angles aren't all the same. Square has 4 equal sides, but the angles are all the same. A rectangle has 4 equal angles, but the sides aren't all the same. So a square is kind of both of those combined, both equal sides and equal angles. And so these are the last things I want you to write down. I hope you enjoyed the video, and I will see you in class.